Dude, get out here, man. I told you, I'm not doing this on my own.
Okay, chill. I just missed the queue.
There is no queue. We were just meant to come on together, you freak.
Oh, sorry. I thought there was a queue. So this is them, huh? The TechEd Massive.
Uh-huh. Largest IT conference ever assembled on these shores, they said.
Hey, you see that Sean Gowley guy out back?
Yeah, he's like a mass whiz or something. He's kinda hot.
And who was that other guy? The one in the red polo?
Yeah, he's another genius. Shouldn't his polo be azure blue though?
You know what? I'd take a red polo right now. I feel naked out here. This crew are all like tech gurus and we're just stick figures. It's embarrassing.
Man up. We're retro. It's all good. Okay, well, buckle yourselves in, ladies and gentlemen. This is Microsoft TechEd 2013.
Roll VT!
Ladies and gentlemen, it's TechEd 2013. Please, welcome to the stage. Oh, thank you very much for that smattering. That's awesome. Just what I expected from an audience which is probably primarily New Zealanders. Who's visiting us from overseas? Raise your hands if you're here from outside New Zealand. Okay, that was what we call enthusiasm in New Zealand. Okay, that's about as good as it gets. But what we need to do, ladies and gentlemen, we've got a very exciting 3.24 days to get through, and we need to start as we mean to continue. So what I'd like to do is, I'll go off and come on again, because to be honest, many of the New Zealanders know what a big deal I am. But for those of you who are from overseas, I'm actually quite a big deal in New Zealand. I'm sort of like an aging Justin Bieber, to give you an idea, if that's crossed with sort of Nick Nolte from his heyday. I'm sort of, for those of you from New Zealand, I'm sort of halfway between, say, .com and the Briscoes lady as far as fame goes. I'm sort of wedged in the, so I'm quite a big D-lister. It's quite a big deal you guys having me here. I mean, obviously I had to do my own intro because we blew the budget on that bloody thing, which was awesome. That was awesome, but to be honest, they kind of went, we've run out of voiceover money. Could you just say you're here and walk on? Which is what I've done, but obviously already it's proving quite a disappointing intro to the 3.5 days. So as I say, I'll go off again. We'll pretend that didn't happen. I can see from the looks on many of your faces, most of you have already done that, which is awesome. And I'll come back on again and we'll kick this thing in the guts. What do you reckon? Good? Yeah, that'll have to do. Even that was like double the enthusiasm of the first bit. Jesus, it's going to be a long 3.5 days, I tell you what. All right, can we drop the lights a little bit? Just a little. No, can we just leave the lights as they are? That's what I wanted. It's like teaching a dog. Do what you want. Good boy. 2013, please welcome D-list celebrity, television personality and comedian. Yeah! Yeah! Awesome! Oh, thank you for that. Oh, that was so off the cuff and what she said! It's exciting. Welcome along, TechEd 2013. Give yourselves a round of applause, because I know that probably hurt doing that big intro. That's awesome. Man, I'm knackered having to come on and off like that twice. I tell you what, geez, I don't know how those athletes do it. Thank God none of you are athletes. So let's... you put your minds into other endeavours, and that's why we're here. It's fantastic. This is TechEd 2013. Now, I've had to write a lot of stuff down because there was a lot of information to get through, so please bear with me as I get through. Right, so my name, as we established, Paul Ego. Okay, so I'm the Master of Ceremonies, the host. I'm sort of like your sort of wireless mouse guiding you through the next 3.5 days, telling you where to go, what to see, what to do, when to do it. When you can go to the toilet, I'll be doing that in groups of 5. Okay, so make sure you wait for your group to be called before you go. Obviously, the next 3.5 days, your chance to connect with other people in the industry, your chance to network with other people in the industry. I've been told that Microsoft TechEd is now in its 18th year. How's that? 18 years. Give that a round of applause. Come on, that's pretty good. That's awesome. 18. I did work out, though, that means that when I was 18, TechEd was negative 21, and that made me feel a little bit creepy. So I sort of moved on from that. Some less dodgy TechEd stats for you. Over 2,500 people attending, ladies and gentlemen. That's pretty damn good. That's awesome. That's great. One guy clapped and then he went, no, it was just me, I'll stop. That's great. Well learnt there. So, message though, obviously, with this many people, don't try and remember everyone's name. All right? You'll give yourself an aneurysm. If they haven't got a name tag, just go, they're not important enough and move on. Now, 162 sessions in 3.5 days. That's, the last session I had lasted about a day and a half, and it took me a week to get over it. So, cramming in 162 in 3.5 days, that's some stamina. I appreciate that. That's awesome. 127 speakers from 9 different countries, each of them speaking 9 different dialects, sometimes all at once. So make sure you're listening would be the little thing there. Now you notice I've gone old school. I've gone the clipboard, you see. I've gone the clipboard because I thought, well, it's technology. Let's get back to basics. Many of you were probably here at the first TechEd when they released the clipboard. Who remembers that? When they brought out the clipboard, they went, look, it opens and there's a thing, look, the paper doesn't fall out. And you all went, oh, I love technology. Some of you are old enough to remember that. Now, there's a thing called the Hub, which you probably visited already, which is down on level 4. 14 exhibitors there, and you need a hub if you're going to have 14 exhibitors. Now, I went down there today, and they've got this amazing thing on the Microsoft stand, and hopefully I'm going to be getting it at some point during the evening. It's a 3D printer, and I had to stand on a little kind of spinny conveyor belt thing, holding my sexiest pose, which was kind of similar like this. I had to hold that and spin around. They make a little avatar of you, a little model of yourself that you can take home, like a little mini version of yourself. It's awesome. So what we're going to do during tonight, in fact, we'll do it now. Have a look under your seat. There's 20 seats in the room here that have a ticket underneath, and if your seat is one of those seats, you can get one of these avatars made. Okay? I should point out it's of you. We're not giving away 20 avatars of me because that would be weird for you to go home and go, look, I've got a little mini Paul Ego. And your partner say, why? And you go, I don't know. So have a look. Do we have any winners? Raise your hand if you found one under your seat. One over here. Awesome, one over there. Good. You can get your avatars made and go home and go, look, this is what I could be like if I didn't eat so much. It's awesome. A little bit smaller. We've got the ultimate prize package, ladies and gentlemen. Now, this is a Surface 128 gig bundle with an Xbox 360 and a Nokia Lumia 925 phone. Now, I had a go on a Nokia Lumia 925 today, and it is a beautiful, beautiful phone, to be honest. I didn't give it back to the guy, so I apologise for that. He'll need to get another one. So it's the Surface 128 gig bundle, the Xbox 360, and the Nokia Lumia 925. And there's also a second prize of a Nokia Lumia 1020. Now, the way you can win these amazing things is with this thing here. Who's got one of these on their wrist already? One of these things? Yes! This is the pathway to glory, ladies and gentlemen. This is what we use for criminals in New Zealand when we can't afford to put them in prison. We just put a little lanyard thing on their wrist and say, just promise you'll swipe it past your house every couple of days. And they go, we will. It's awesome. But you can also use it here. Now, I use mine at home. This is great because it's like, what do they call it? It's a near-field communicator. You've probably heard that before. So you swipe it near stuff and stuff. I use this at home. Like I go past my kids and I swipe it past them and they run off and they do their homework. And I go past the cats and I swipe it past the cats and they run off outside and I swipe it past my wife and she takes off somewhere for a couple of weeks. I'm not quite sure what happened there, but it doesn't work for all of them. But it works here. I tell you what. Now, it does so much, this little wristband. It does so much that I've actually compiled what it does into kind of like an infomercial sort of thing that I'll read out because it sounds like something you would hear Suzanne Paul, who is a model here in New Zealand. It sounds like, that's only funny for the New Zealand people. It sounds like something she would advertise. So so this is what the wristband does, okay? TechEd 2013 Industries presents the NFC wristband, ladies and gentlemen. Your life will never be the same. You can use your NFC wristband to check in each day, to get yourself a Coke from one of the machines, to collect points when you get into sessions. And with each session you attend, the more points you get than the last one. But wait, there's more. It does so much more. The amazing NFC wristband will allow you to check into TechFest on Thursday night, and with its amazing new slimline technology, it will get you a better night's sleep while also making you better in bed in the long run. It will also cook you a roast meal within 30 minutes and give you rock hard abs in less than 6 months. Some of these things may not be true. The NFC wristband. Get one today. So make sure you go and grab one. If you haven't already, get one. They never come off, by the way, but once you've got it on, the things you will get. Make sure you use it to check into every session. You'll get points. The more points you get, the more chances you win. You guys know how it works, definitely. So make sure you get one of those. Now, I've mentioned the little avatars. Those people who won those are going to get a chance to get one of those. Also, we should mention tonight, one of the main reasons we're here is to hear from some very important speakers, some keynote speakers. They're going to be saying a few words. Sometimes they'll put them into a sentence format so they sort of make sense. Other times they'll just throw words out there and you guys can assemble it. You're all pretty brainy, you can do that. I'll just tell you a bit of a lineup of who you're going to be hearing from tonight. First of all, we'll hear from certainly one of my favourite Nigel Parkers, the one from Microsoft. Microsoft's Nigel Parker. If you're going to get a Nigel Parker, he's certainly the one to go for. Now, Nigel is the Director of Development and Platform Group at Microsoft. I have no idea what that means, but it sounds like he drives a nice car. Then we have Mr. Scott Guthrie. Now, Scott is visiting us from that big place called Overseas. I'm not sure if you've been there, but it sounds like it's pretty exciting. Scott is the Corporate Vice President in Microsoft's Server and Tools Business Division, which is a bit of a mouthful, so I think we'll call it Corp Vit Misbid. Just easier to say. In fact, let's all do that now. Corp Vid Misbid. Everyone, Corp Vid Mis. See how easy that is? So let's just call him that from now on. So we'll be hearing from Scott. And then following Scott, I'll be introducing our closing keynote speaker for today, a man who has a PhD in physics from Oxford. He's worked at NASA. He's a 2-time New Zealand track and field champion. And he's won the 2012 World Technology Network Award. So hopefully he's here to tell us how he's planning to get off his ass and achieve something at some point. So, okay, I'd like to introduce a man who's... gives me a lot of pleasure to introduce him, about 50 gigs if I had to put a number on it, of pleasure. He's from Microsoft New Zealand, and as I mentioned, certainly one of my favourite Nigel Parkers. I've had a few in my time, and he's been had is the wrong way. I've met a few. Let's start again. Should we? We can edit that bit out, to be honest. We're not that close, all right? We'll see how the night goes, obviously, but we're not that close. I'll just bring him out, shall I? Might be a good idea. Ladies and gentlemen, from Microsoft New Zealand, Nigel Parker!
Well, the best part about that is that Paul did none of that in rehearsal, so that was all new to me. And I'm not going to be joining you later. And I drive a Subaru. It's a really nice Subaru. There's a lot of people here. Most of the people here are probably like me. There's a lot of introverts. Hands up if you're an introvert in the room. Gotcha. The world sees us as builders, people who follow instructions to create systems. And I see myself more as an artist, as I'm sure many of people here do. A kind of creative refiner. We know what to do with white space. There's 100,000 of us here in New Zealand in the ICT community. It's about 2% of the New Zealand population. And as a whole, we contribute $23 billion to the New Zealand economy. It's about 10% of the country's GDP. And there's 3,300 Microsoft companies, partner companies here in New Zealand. And there's roughly about 2,000 people here today in this room, representing 500 companies. This is who we are. I want to welcome you to TechEd 2013. And I encourage you, as Paul said, to spend some time over the next 3 days going to sessions that challenge you. 128 speakers, some of the best speakers here in New Zealand and from around the world. And I want to challenge you to go to sessions that you would not necessarily want to attend. If you see a title of something that's interesting, that might, I don't know, not be your normal kind of session, check into that. Check it out. We have 22 sponsors and exhibitors, and I'd like to thank them for spending the time and coming here and presenting with us as well. Amongst us includes students like Ray. Ray has built applications, 2 games for Windows Phone and Windows 8. He's got 1.5 million users across his games, and he increases about 150,000 users per month. He's made $58,000 from his games in the last 12 months. We also have app agencies like Market Metro. Market Metro didn't exist 2 years ago. They now have 14 staff here in Auckland who all they do is build applications for Windows and Windows Phone. One of the first games that they built, AlphaJax, is built just for Windows Phone using Windows Azure, and it's got 3.5 million users around the world. Think about that for a second. That's more users than Xero and TradeMe put together. I use Windows 8.1, Windows Azure, and Windows Phone every day in my life. I've written 3 apps across all 3 platforms, with more than 28,000 users here in New Zealand. And it's not just me. I think New Zealand punches above our weight in regards to the companies and the people who are building apps for this platform. We've got 1,500 developers, New Zealand developers, registered in our stores. And they as a whole have shipped more than 1,280 applications. And a lot of those applications are for the local market, but there's a lot of global apps with massive numbers of users, like I used in the examples before. This is my Windows 8 phone. You probably saw coming in the photos on the lock screen. A lot of those photos, I took all of those photos, and I took a lot of them using my Windows Phone. I have the applications and the experiences that are close to me available on my display, so I can just look and glance and see stock prices, check what's going on with the people I care about, and have a look at the local and global applications. And when I throw my device to my daughter to keep her quiet in the back of the car, she also has an experience on this device using Kids Corner, where she can get in and access her Xbox Music or her applications that she wants to experience. And this is my Windows 8.1 desktop. I have a few computers, as you might attest to, many people in this room. And I love how the experience follows me when I lock into my Surface Pro or my Surface RT or my computer at home. And that experience of my favourite apps and the people I want to keep track on follows me around, so when I log into those different devices, I get that same experience. And I do have an announcement for those here today. And anyone who is on Twitter, which is probably most of the people in the room, probably have already seen this early this morning. But we've taken some feedback. So we're going to release Windows 8.1 and Windows Server 2012 R2 on the 18th of October with new devices coming out to the general public. And last week we announced that those products went to RTM. And we heard you loud and clear that we are making those available, or we made those available this morning to MSDN and TechNet subscribers. So that's an example of feedback from everybody in this room coming back to us and us turning that around. So I hope you appreciate that. Collapse. We've also released this morning Visual Studio 2013 Release Candidate, so that you can start to build modern applications against Windows 8.1. Windows 8 is growing share, and it is growing share fast. I just want to share some numbers with you. Windows 8 has more users than all versions of OS X put together now. Here in New Zealand, the data is showing us that Windows 8 is being used every day by New Zealanders more than iOS and Android. And there's a new trend of line of business tablet apps as well. This example here, Datacom has been working with Sealord to produce a stock management application using Windows 8. And this application is back-ended onto Dynamics CRM, and it's just one example of how the partners and businesses are coming together with these new devices to create next generation experiences for their customers. This is one that's available now and is already in use by Sealord, but there's plenty of other examples out there of apps that are being constructed. And the great experience of this is that for the IT pros in the room, these systems can be managed, they can be bought in with every other device that you're operating against, and operate with the new touch first interface in mind. The only true voyage of discovery is not to go to new places, but to have other eyes. And I believe the greatest creations come from those of us that are prepared to dream and to take action. A couple of months ago, I was up in San Francisco. I was lucky enough to go to Microsoft Build conference, our big annual developer conference. And I saw this little guy. This is a collaboration between Microsoft and Lego International, where we've built a Surface Pro robot using the next generation of Lego Mindstorm's EV3 kit. And this kit is designed to get young people into programming. So if you have young people who are thinking about a career in ICT, it's a great way to get them engaged. And Clint, who was behind building this robot, is here at Microsoft TechEd, and he's going to be on the stand on Friday showing this guy off. So I encourage that you go and have a look at it and check it out for yourself. And talking about startups and new ideas, startups are growing in New Zealand quite considerably. Over the last 5 years that we've been running Microsoft BizSpark here, we now have 550 startups on the program. And last year alone, we gave $120,000 worth of Windows Azure access to those startups to extend and to develop their solutions. These startups are actually taking advantage of devices and services that simply didn't exist 5 years ago. And you can leverage these devices and services as well. And I encourage you to attend sessions and to start to experience how all these pieces come together. So let's hear from a few of these startups now and how they're using Windows Azure.
So Green Button, we've built a platform for managing high-performance computing and big data workloads on the cloud. Without Windows Azure, there's absolutely no way we'd be able to do what we do and service the customers that we do. You know, for example, where they need 10,000 calls to process some job in 2 hours instead of 5 weeks. We couldn't keep up with that ourselves. So one really exciting example is that Green Button has helped one of the studios in Mexico render the first full-length animation film entirely on the cloud. So that studio has no on-premise render farm or facilities, and they calculated it would have taken around 13.7 years to render that film on their workstations, and we rendered that in 3 months. What I'd say to developers who are thinking about Windows Azure and whether it's right for them, you know, all of the developer tools are exactly the same as what you're doing today. It's a very low barrier to entry platform. And so use it now. Actually, maybe wait till after Scott's finished his keynote, but then go and play with it, and you'll be surprised at how easy it is and how empowering it can be for your business.
TranscribeMe converts voice to text. We do it very fast with perfect accuracy. We've been going through fast growth in the last few months at about 40-50% per month, and being able to scale up our server infrastructure has really helped us support that. Without Azure, I don't think our business would have been possible even a few years ago. Through our membership in the BizSpark program, we've been able to get access to top Microsoft architects. Another great benefit with BizSpark is that you get cloud access for free while you're getting started. Right now, in the world of startups, speed to market is critical. The only thing that you can't buy is time.
Timely is a cloud-based appointment scheduling system. We have a real range of businesses who use the product, and it's very popular in the health and beauty space, so clinics and salons. Our business is growing quickly, and so we needed a platform that would scale with us quickly and that was easy for us to scale. And that's exactly what Azure provided us. So we can add more infrastructure when we need it. And as I say, the business is growing fast. We're in 17 countries in less than a year. And we're growing at about 30% month on month. So we need to be able to do that and not have to worry about all of the infrastructure stuff that comes with it. It was very exciting getting Yammer on as a customer. And I thought it was some nice serendipity that they are a Microsoft-owned business as well, because you know we've been all in on the Microsoft stack since we started. and we've had a lot of support from Microsoft and BizSpark and the Windows Azure platform.
Turn my mic on. Turn my mic on. There we go. Okay. Ladies and gentlemen, put your hands together for Nigel Parker there. Thank you. Nigel, awesome. Nigel, he is a Subaru driver, but he drives it like a Lamborghini. Man, tears it apart, that thing. It's amazing. Okay, we're going to welcome now our next speaker. As I mentioned, he's from overseas, and I saw some of his presentation today during the rehearsal, and tell you what, there's a twist at the end there that I just did not see coming, so I'm looking forward to what you guys make of that. He's got the handshake of a gorilla and the legs of a gazelle, and when he's not doing this, he also he's known as Red Wiggle. Please welcome to the stage, ladies and gentlemen, Scott Guthrie!
Well, it's great to be back here in New Zealand, and thank you for the great introduction, and really looking forward to spending a couple days with you, talking a little bit about some of the great things coming out of Microsoft. And what I'd like to do this afternoon is just spend a little bit of time talking about one of the things that I'm personally working on, which is Windows Azure. For people who don't know, Windows Azure is Microsoft's cloud computing platform, and it's basically a really powerful way that you can take your businesses to the next level and really do, I think, some interesting things with them. One of the things that's nice about Azure is some of the core tenets that you kind of see reflected throughout all the feature set, and you'll hopefully see in some of the sessions as well as some of the demos I'll do a little bit later today. One of the nice things about it is it's super flexible. We've kind of built Windows Azure so that you can do just a dramatic number of things, ranging from infrastructure services that you can use in order to stand up any virtual machine, whether it's running Windows or Linux, with any workload you want on it, with any type of virtual networking to connect to your on-premises environment, to powerful application services that you can use to power web applications, mobile backends, big data, analytics, and a variety of other scenarios. And I think hopefully you'll see that kind of reflected again in all the demos of just sort of the flexibility that it provides. It's also very open. I mentioned just a moment ago both Windows and Linux, which you might not always expect at a Microsoft developer event or an IT professional event. And that's one of the kind of the things that we've tried to embrace with Azure, though, is this notion of openness, where you can use any operating system you want. You can use any database stack you want. You can certainly use SQL. We'd like you to do that. We also recently did a partnership with Oracle, where you can now bring the full Oracle database as well as application stack and run it inside Azure as well. And that's just sort of one example of our openness. On our mobile backend side, you can target Windows 8, you can target Windows Phone, but you can also target iOS and Android as well. And this is sort of, again, reflected throughout the stack and gives you lots of different choices. And then the other thing that's nice about Windows Azure is something we call consistency. And that's basically our kind of goal of being able to run Windows Azure as a service that we provide in our own data centers that you can use to host applications anywhere in the world. But at the same time, we're also making sure that you can take advantage of those features within your own data centers, on your own hardware, or in another service provider that's running on top of Windows. And through something we call the Windows Azure Pack, you now can download a core set of the Azure functionality and have the same consistent admin tool, management scripts, as well as infrastructure and some of our platform features run basically everywhere. And that gives you, hopefully, both as developers and as IT professionals, a cloud environment that ends up being super powerful and something that hopefully will get you excited about this week. One of the things that's nice about Azure is it's deployed around the world now. And over the next 12 to 18 months, you're going to see us continue to expand the Windows Azure footprint pretty dramatically. We're now in more than 10 regions around the world that are live, and we're going to have another 10 opening up, again, over the next 12 to 18 months. In the Asian Pacific region alone, we're actually going to have 8 regions that are dedicated to the Asian Pacific. We have 2 already in Asia. We have 2 opening up in mainland China. We've got 2 opening soon in Japan. And we're really excited. We announced a few months ago that we're opening up 2 new regions inside Australia that we think will also be great for the New Zealand market. And what's nice, again, as a developer IT pro, any application you build, you can go ahead and deploy in any of these regions. And so that gives you both global coverage, and it also means, you might ask, why do we have 2 regions in Australia? It also means you have disaster recovery built in. where you know that you can actually deploy anywhere, and in the event of a natural disaster happening or something like that, you can also move your workloads somewhere else and basically rest assured that you can run your business successfully on it. And we think this kind of global coverage, coupled with all the features that we have, are going to make it really powerful for you to build applications and really reach a global market. Now, people often ask me, so what does a region look like? Basically, within a particular region, one of those little circles, we have data centers. We usually have multiple data centers in each region. And what I thought I'd do is just show a simple video of kind of what a typical region looks like and what your applications are actually running on inside Windows Azure. So this is a video of one of our data centers. You'll notice we have containers. They're full of servers. We have tens of thousands of servers, sometimes in each container. We don't have many people in the data centers, but the ones we do have are very strong. And basically, they wheel in these containers. They hook up power. They hook up cooling. And from that point on, it's pretty much a lights-out operation. And so when you, as either an IT professional or as a developer, use a script or a portal or a development tool, and you deploy an application or you monitor it and you say, I want a machine stood up or I want a database stood up. Basically, you're firing kind of REST web API calls to this data center, and we completely automate provisioning that infrastructure for you and standing it up for you to use. And that ability ends up being super powerful because at any point in time, you can go ahead and ask for resources. It also ends up being super cost effective because all of the infrastructure you deploy in Windows Azure uses what we call a pay only for what you use model, which means that if it's not running, you don't pay for it. There's no upfront license costs. There's no obligations, long-term commitment. You can basically stand up and stand down infrastructure as you need it. And again, only pay for what you need to use. And I think that the power of all that infrastructure, the global reach, and then the cost savings that it can deliver end up really being a very valuable business proposition. So what I thought I'd do is let's skip out of slides and let's actually do some demos and actually show some of this in action. And what I thought I'd do is just kind of give you a kind of a brief intro of Windows Azure and walk through a few infrastructure scenarios that hopefully motivate how you can get started and some of the easy things you can do with it. And so what I'm doing standing right in front of here is our Windows Azure management tool. And this basically gives you access to all the different Windows Azure resources that you can deploy in the cloud and gives you kind of a nice view on top of what's happening inside it, and you can go ahead and easily create and deploy things in a matter of minutes. So what I'm going to do to start off with here is just go ahead and create a new virtual machine. So we're going to quick create. What would you like to call this virtual machine? Dennis. Okay. Dennis the sailor. There we go. We're just called Dennis. You can pick Dennis from a variety of virtual machines that you might want to deploy. One of the things you'll notice here is we have lots of built-in images. We've got Windows Server, multiple versions of them, including the new Windows Server 2012 R2. We've got SQL Server images, BizTalk. We got even a Visual Studio Ultimate 2013 image if you want to try out the new VS 2013 without having to install it on your local system. And we also have a bunch of Linux images. So you can choose from a variety of different Linux distributions. I'm just going to use Windows Server 2012 R2 here. Add myself as an administrator. I can then choose where in the world I want to deploy it. And just hit create. And that literally, in a matter of a few seconds there, is all I need to do in order to actually stand up and create a new virtual machine that's dedicated to me, that's running vanilla version of Windows Server. And in a matter of about 3 or 4 minutes, I'm going to basically be booted up in the eastern half of the United States, and I can basically now administer this and do whatever I want on it. And that hopefully gives you a sense of just how quickly and easily you can go ahead and get started. Now, just so we don't have to wait for it booting up, I'm just going to go ahead here and click on a virtual machine that's already deployed. And you'll see when I drill into it that we have a whole bunch of diagnostic information that we provide out of the box. So I can see CPU, memory, bandwidth, disk I/O built in. I can go ahead and connect to it just by clicking the connect button. And I'm going to log in. And what you'll see here is I'm connecting to this virtual machine. And in a matter of seconds here, I'm logged in. I'm a full administrator on the machine. I can basically do anything I want on it. I can do PowerShell. I can use Server Manager, built-in Server Manager here inside Windows. And I can basically attach disks. I can attach virtual networks. And everything I do inside here, I have complete control over. If I go ahead and save it or power and reboot the machine, all the settings will still be there. and I can now go ahead and run pretty much any workload I want within that using the skill set and the tools that I already have. Now I can do this, I can run these sort of standalone machines pretty easily just by literally clicking the connect button and doing it. I can also, for more advanced scenarios, enable what are called virtual networks. And what this lets me do is kind of define my own network that I can choose to make either public or private. And I can go ahead and attach multiple machines too. And so this is an example of what I call ScotGoo Virtual Net. And you can see here I've defined a subnet as well as an IP address range for this virtual network. And I can define whatever subnet or IP address range I want. If I was an enterprise, I might, for example, want to have it mapped to what my corporate intranet network looks like. I could also wire up DNS servers that might be behind my firewall and attach it to this virtual network as well. And the other thing I've then done here is establish what's called a gateway. And what this is going to allow me to do is I can take my on-premise network and take a standard Cisco or Juniper router or software-based VPN solution and stitch it together with Azure and form a giant virtual network that's private to my enterprise. And then I can basically mix my on-premise hardware and my infrastructure in the cloud into one single network and have them interoperate. We can also take advantage, and if I want to, I can enable something called point-to-site virtual networking. And what that lets me do is I can take any standard Windows machine, and I can then just simply go ahead and VPN into Windows Azure from it. So you can see here, I can connect. In about 3 seconds here, boom, I'm now on a virtual network from my PC laptop to my server actually running in the eastern half of the US. And you can see now I'm connected to that ScotGoo virtual net. And now any of the machines that are in Windows Azure, I can now connect to over that virtual network. And so as an example here, I'm going to connect to this other ScotGoo demo VM1. Now this machine happens to be running on my virtual network. So if I zoom in here, you can see it's running my virtual network. One thing you'll notice here is there's no public IP address for this machine. So I put it on a virtual network running in Azure, but I've shielded it from the rest of the world, and I'm only allowing machines to connect to it from my intranet or from a VPN that I'm actually tunneled into. And so you can see here there's no public virtual IP address, but there's an internal IP address of 10.0.1.4. And I can very simply now connect to it, 10.1.0.4. And again, in a matter of a few seconds, I can go ahead now and securely connect to this machine, just like I would a machine that was down the hall from my office in my corporate environment. Again, I'm a full administrator on it. I can do anything I want with it. I can run any workload. And that's literally how easy it is to start standing up virtual machines, connecting to them, creating virtual networks, linking them all together with your on-premises environment, and really starting to stitch these things together in unique ways. So that hopefully gives you a kind of a brief sense in terms of kind of some of the things you can do here. One last thing I'll just kind of highlight that I think is kind of nice, and I kind of mentioned in some of those themes that you hopefully see reflected throughout Windows Azure, which is this notion of consistency. And part of the goal with the consistency is, you can take your private network, you can take our network, you can put them together, and you can integrate, and you can do it in a consistent way. The other thing that we're trying to do is basically use the same software stack in our data centers that we enable you to run inside your data centers. And so we use the same Hyper-V-based hypervisor inside Windows Azure that you get with Windows Server 2012. And in fact, this virtual machine that's running inside Azure is being persisted to disk inside Azure, and this is a little storage explorer that shows you the disk inside Azure as a .vhd file. And so basically when I created this image, it's literally persisted as a standard VHD file. If I wanted to, I could download it to my local desktop, and I could just boot it up using the hypervisor that comes built into Windows. There's no import-export process required. It's literally the exact same file format, running the exact same copy of Windows inside it. And that gives you a tremendous amount of flexibility where now you as administrators or as developers can basically choose where you want to create and run your virtual machines, whether it's in our data centers, your data centers, or another service provider. If we go back to the slides, I'm going to show a simple example of what that means. So hopefully you saw here, run any workload, whether it's Windows or Linux, attach any storage you want to it, create virtual networks. and basically run anything you want inside these VMs. And again, the benefit of that virtual machine portability is if you've already got a virtual machine running in your on-premises environment with Hyper-V, all you literally need to do is just upload it into Windows Azure, and you can boot it up. And you can pay by the hour, or actually pay by the minute, and there's no upfront cost, there's no license cost. You can just use those same licenses and the same software you already have. If you want to, you can take that VHD that we just created, Dennis's, you can download it and run it, again, inside your data center environment. It just works, no import-export required. And then, if you want to, you can also go ahead and run it in any number of Windows service providers that run Windows Server, and you can basically import and export those VMs from them as well. And that ability, again, to run all those things consistently in all those different environments, use the same tool set, the same developer skills across all of them, again, we think is really powerful. Ends up giving you lots of options, avoids you having lock-in, and lets you build some really great solutions. So I thought I'd talk about a customer that's actually already taking advantage of this today, and you might have heard of them. When I was in Australia last week, they promised me, or they made me promise that I wouldn't actually use them as an example in my TechEd Australia keynote. But I'm very happy to talk about them today, which is the All Blacks. And their website and some of the backends that they use for their mobile experiences are in the process of moving to Windows Azure. By the end of the month, they'll actually be fully moved over. We're running on top of Windows Server and .NET today, and an existing on-premises environment. And what they found is when there were games, they often got flooded with a lot of demand for their site. And the cloud is a perfect example of how they could go ahead and spin up resources when they needed them, and then go ahead and trim down the number of resources they didn't need when there weren't games or there wasn't as much demand, and they could realize a whole bunch of cost savings. This symmetry and this consistency model that we have enabled them to very easily move their CMS system using virtual machines, just like I showed here earlier, and literally lift and shift it from their existing environment into the cloud. And then they started to be able to take advantage of the full Azure feature set in order to actually run some of their front-end websites using our platform as a service features as well. And I have a quick video here showing and talking about it in action. So let's go ahead and roll the video.
We're a design-led organisation and developing technology solutions for really a global market. We're a Microsoft-only shop. That's all we do, so it keeps our focus tight. And that's why we've picked Azure, because it's at the front of the curve. Cloud is really going gangbusters today. We're actually banking on their investment, and that's making our lives easier every day. We started working with New Zealand Rugby a while ago when they wanted to first move some of their workloads to the cloud, which was their email and BPOS. New Zealand Rugby acknowledged that their fan base was growing hugely, and they wanted to pick a modern platform that had a true future. And I guess that's why they've selected Azure, and that's why they're working with Provoke.
It's hugely important for us to be able to migrate our existing assets over into the Azure environment. So, working with the guys at Provoke, we've been able to take a phased approach and bring over, our assets that we already had, enabled us to get a good cost-effective result.
I think, the key message from All Blacks is wherever the fans are, they'll have a solution. So we know that the fans are going to be flocking to Windows 8. We know that they're going to want an app. So it's certainly got to be a focus. Stay tuned.
Cool. So the All Blacks website, in the process of moving over literally right now. By the end of the month, they'll be running on top of Azure. And we're really excited to have them as a customer. The other thing that I'm excited to announce today is a new official All Blacks app for Windows 8 that you can go ahead and now download from the Windows Store. And this basically provides an immersive experience for the All Blacks. And it's a V1 of the app. You'll see even more improvements coming. And the great thing about this mobile app is that it's actually also, the back end is running on top of Windows Azure. And it's able to take advantage of the cloud scale in order to elastically scale up and meet a variety of different immersive needs. So that's a little bit about some of the infrastructure and some of the things that you can do where you can leverage your existing code. You can use that same consistent virtualization technology in a variety of different environments. I want to switch gears a little bit now and talk from a developer perspective about some of the other capabilities that we provide in Windows Azure that we call Platform as a Service. And these are basically developer building blocks that we provide and that we run as managed services. And this means that we actually take care of a lot of the infrastructure for you. We handle running the VMs for you. We handle patching the VMs for you. And it sort of allows you to focus more on the app, both developing it and operating it, and end up being a lot more productive as you kind of build and scale out your experiences. And this is just sort of a small sampling of some of the built-in Windows Azure services that we now provide. And we're doing constant updates pretty much every 2 weeks, rolling out new features and new services that you can start to take advantage of. And what I thought I'd do is show a quick set of demos here of how you can take advantage of some of these today. So we're going to go back to our admin tool here, and we created our virtual machines. What we're going to do here now is create a website as well as a database, and kind of just sort of illustrate a little bit some of the productivity and some of this kind of managed hosting capabilities that we provide. So we're going to create a new website, very similar to how we create a virtual machine, but instead of saying new virtual machine, we're going to create a new website. And we'll go ahead and name it. What would you like to call it? Okay. Quiet Sailor, or how about 3 minus 2? 3, 2 minus 1, sorry, no, not 2. That's a sailing analogy if you haven't seen it, but you're doing well. So we're going to go ahead and create a new website here. And what you're going to see here is it's pretty quick to create a website. So we're standing up this new website here in the East Coast of the US. And you can see it took about 7 seconds to create, so pretty fast. Now I can click into it. And right now, I don't have any code deployed, so you'll notice I don't see any CPU or any kind of input coming in. Let's go ahead and fix that and by dropping into Visual Studio and creating a new app. And so we're going to create this new app. We'll call it 3 minus 2. I'm going to take advantage of the new VS 2013 and the new ASP.NET capabilities that are built into it. And so I'm going to create a new website. We have a bunch of great new features coming as part of this ASP.NET release. You can now easily mix and match MVC, Web API, web forms in a single project, so you can take advantage of code assets from a variety of mechanisms, and a bunch of great HTML editing features, as well as tooling support coming as part of this. It's a really nice release. This is just a standard ASP.NET project, though. But what I'm going to do here is rather than do too much coding here, is just go ahead and publish it and run it inside Azure. And so to do that, I can go and right-click on this project in VS, hit Publish. I'm going to link it up to that website that I just created. You notice we have built-in publishing support now inside VS. It's automatically, you can talk to Azure and pull all the publishing settings literally without you having to look anything up. I can then go ahead and start publishing. And this is going to go ahead and deploy this fairly large app all the way around the world. Literally, in a matter of a couple seconds, we should see in about 5, 4, 3, 2, 1. Boom, there we go. That was pretty good. But you can see basically we just created a new website. We went ahead, built an app in Visual Studio. We deployed it. It's now running in the cloud. And I didn't actually have to stand up any infrastructure to do that. I was able to kind of use our website programming model for it to handle automatically all the load and all the infrastructure. Soon I'll start seeing some of the statistics start showing up as it starts seeing some load. And so you'll see in a little bit that'll start populating inside it. What I can do also is, in case my app becomes as popular as the All Blacks website, which is highly doubtful, but just in case it was. One of the things that's nice about kind of our model here is I can automatically scale it up and scale it down as I need to. So I could choose what size machine I want to run this website on. I could also go ahead and just say I want 2 of those 3 instances or 4 instances of those VMs. And all I need to do is hit save, and this thing will automatically scale out across all those servers. Or alternatively, one of the neat things that we provide is what we call auto-scale support. And so all I need to do is just go ahead and say, I want to scale based on the CPU of my servers between 2 and 7 VMs. And what I want you to do is just try to keep it between 31 and 72% of CPU power. And what this means now is if my web servers ever drop below 30% utilization, we'll start shutting down VMs automatically. So I'm not actually having to pay for those VMs. If my website traffic starts spiking up and my CPU goes above 72%, we'll automatically start adding VMs and web servers back into the pool so that you can actually keep up with demand. And literally, just by hitting save and waiting about 6 seconds, there we go, it's 4 seconds, sorry. I basically now have an auto-scaled website for that 3-2, built in Visual Studio, deployed in the cloud, and I can now elastically scale up and down. And you can see here it's already saving me 71% of money because my site right now doesn't actually have that much traffic, and so it's automatically scaled me down to just the minimum instances I need. So, simple way you can go ahead and stand up web infrastructure. The same is true for databases. So let's say, for example, I want to create a new database to go along with my website. I could quickly create one. We'll go ahead and call this, what would you like to call this database? Fred, okay. There might already be a Fred database, but we'll see. So we're going to create a Fred database. I often ask people, when you need to create a new database for an app, or you need to order or license a new copy of SQL Server, how long does it usually take? Usually, for most IT departments I talk to and developers, it's about 6 weeks. We can do a little better than this. Basically, hit create. 1 1000, 2 1000, 3 1000, 4 1000. There we go. 4 seconds. Our database is created, deployed, stood up, and ready to use. So you can click on Fred. I have a new created database. I can use the same SQL Server Management Studio that I can use with my on-premise SQL servers. I can use the same ADO.NET and Entity Framework Data Access APIs to program against it. So I can use the same development tools and the same management tools that I'm familiar with. And the beauty here is, just like you saw with websites and VMs, I can now get a nice dashboard view that'll show me the health of my database. I can now grab a connection string, start programming against it, and literally in a matter of seconds, I now have the infrastructure I need in order to start powering my applications. And right now, this particular database, we created, I think, a 1 gig database. So it's, I think, roughly $12 a month. There's no license fees. There's no upfront costs that you need to pay. So you just literally pay for what you use. And if you ever need to scale up and you need a much bigger database for your application, again, just click the Scale tab, pick the size of the database you want, hit Save, and in a matter, again, of about 5 seconds, you can see we've now scaled up to be a 150 gig database, literally pretty much in real time, and now I can store any data I want in it. And because it's running as a service, we'll automatically back it up for you. We run the database across 3 physical servers, so you also don't have to worry about high availability, and you can really start focusing on your applications and delivering the value into your organization in a sort of a rapid pace that probably you might think of as significantly faster than what you possibly do today. And again, the beauty is all the stuff, both the virtual machines plus the platform as a service features I mentioned here, you can run anywhere around the world, and again, uses the same skill set and the same technology that you use on premise or in a private hoster today. So let's go back to the slides. I talked a little bit and showed some demos here in terms of some of what you can do with these features. What I thought I'd do is also just sort of introduce, and these were just a few samplings of some of the types of capabilities we have. In addition to kind of web and database, I could spin up Hadoop clusters and do MapReduce jobs. I could store petabytes of data. I could do media streaming. I could do single sign-on with Active Directory and our hosted Active Directory service and a lot more. But I'll leave some of the sessions here this week that you can attend to learn a little bit more about those, but hopefully I got you interested with just those 2 simple demos earlier. Rather than just sort of show you my hello world, what I want to do is kind of introduce a few great New Zealand customers that are already using Azure today. This includes governments, this includes the New Zealand Police, and this includes great companies like Serco that do a variety of travel and airplane service. And I want to roll a quick video of them talking about some of their experiences with Azure and how they're taking advantage of some of these capabilities.
We've used Azure because it enables us to use our existing skill set within, say, our Microsoft tools and take them onto the cloud. So take advantage of scaling websites, scaling the database on demand. In a nutshell, for OSC, we've created a system that allows them to extract their data from their source systems, and they wanted to enable it to unlock it so their end users could get access to that information. The Azure toolset gave us the components that we needed to get the job done, to give the clients what they needed.
This is a very groundbreaking and innovative project. The vision we have is to give people access to all of our data and give them sensible ways to view and chart the data or look at it on a map. So it's giving much wider access to a much wider set of data than anyone else is doing. We don't want to be on our own on this one. And the way we've built this is so that it can easily be shared. We want other people to use this platform with us.
The product we started with was open source. So we've talked with the team that's created that, and we look at contributing those changes back to the project that we took it from. But over and above that, the contributions can be used wider inside the ASP.NET environment. And we also see that some of the tool sets that we've created also can be used in the wider Microsoft development community.
So Signal is a social media monitoring tool that monitors publicly available social media feeds. The intent is for public safety and emergency management organisations to use that information as part of their mix in order to help them achieve the goal of situational awareness. Signal as a product is based in Azure, in the cloud. So no matter what the size of the events or the response requirements, our customers know that they're never going to run out of data and they're always going to be online. An important strength of Azure is that it offers Signal almost infinite scalability.
Signal came about through a proof of concept through Rugby World Cup. Allows us to really get the pulse, I guess, of what's happening out and about and allow us to provide information to decision makers so they can act appropriately. Well, it's real-time information, so we're not impinging on privacy. It's information that's coming from the public that they're putting out there that we can sort of make use of in an operational environment.
So we know we're on the right track with Signal when you're invited to something such as Microsoft City Next, which is a global initiative designed for the betterment of cities and the citizens within those cities. You know you're doing well, and Signal is an ideal fit for that, taking advantage of the communications paradigm that is social media.
Okay, Serco is in the area of providing travel management and booking systems to the corporate and multinational market. We have clients from 500,000 travel spend up to 380, 400 mil. Windows Azure has allowed us to focus on our application set and not worry about the infrastructure side. It's been a very successful move on both the revenue side and the cost side. Our cost savings through a standardised platform has been, our savings are considerable. Have a play, go into a pilot, feel the ease of use and the scaling that they can provide their application, software as a service type apps, and pretty much the rest is history. It really takes over from there.
Sure. So there's just a couple of examples of some of the customers that are deployed here today, and again, some of the success that they're able to have with it. One of the things that often people ask is, what's a good way to get started? One is if you can do a new pilot or just try out a project. That's a great way. And hopefully you saw here, it's pretty easy whether you're moving infrastructure, whether you want to do a web or mobile backend. It's really easy to get started. Another thing that you can do to take advantage of is use Azure for dev tests. And this is often one of the simplest ways and the most immediate kind of return on investment for a lot of enterprises and organizations. And we think kind of the cloud is really good at. One nice thing about Azure is, as I mentioned, you pay only for what you use. So if you stop a virtual machine, if you turn off a resource, the billing stops. And so you don't, in a dev test world where you're often spinning up and spinning down infrastructure, the cloud is kind of ideal where if you don't need it running, just turn it off. You can stop paying for it. Other nice thing about Windows Azure versus other cloud providers is you charge by the minute. So if you only run something for 20 minutes, you're not having to pay a full hour. You're only paying for 20 minutes of usage. And so again, it's great for that dev test world where you spin up and spin down pretty frequently and pretty fast. One of the things that we've done earlier this summer is extended MSDN use rights to all of Azure. How many people here are MSDN customers? A number of people. Basically what this means is you can now take all of your existing MSDN licenses and you can just use them for free inside Windows Azure. And we're basically providing discounted rates for all virtual machines. saving you up to 97% off of the standard rate. And you can basically use kind of a standard dev test price, any number of virtual machines. So if you want 30,000 virtual machines, you can spin them up. You might need to call us first and just make sure we can verify who you are, but you can spin up 30, 50, 60,000 machines. We have some customers that do that. And you can basically do it at a significantly reduced rate over what both we provide in our standard production rates, but also versus any other cloud provider out there. And again, you can spin up any number of these if you're an MSDN customer. We've also then made it even better for MSDN customers by making sure that every single MSDN subscription comes with what we call free credits. And what these are monthly credits in dollar value that you can then spend on any Windows Azure resource. So you could spin up VMs, you could spin up websites, you could spin up databases. And these credits renew every single month. And so if you're a professional subscriber, you get $70 a month, premiums $130, ultimate $200 a month. And as an example for premium, that's enough that you could spin up 3 virtual machines for 16 hours a day, 31 days of the month. And you never have to pay anything. That's just included as part of those free benefits. You could also spin up 80 VMs for a 20-hour load test before a project goes live. You could spin up 50 HD Insight nodes if you want to do a giant MapReduce job. Or you could spin up over 100 websites and databases. And again, you could do all this literally without having to pay anything. When you just sign up with Windows Azure using your same Microsoft ID that is associated with your MSDN, we won't even ask you for a credit card. You're in the system immediately. And then directly inside that portal, you can always click and see how many credits are remaining, as well as what's my burn down rate look like for what the rest of the month continues. So there's never a surprise. You never have to pay anything. You don't even have to enter your credit card. And you can actually start using Azure for dev test, literally for any scenario. And just to make it even better, we have a special offer through the end of this month, which is if you're an MSDN customer and you sign up for windowsazure.com and you deploy anything, simple website will do or a VM will do, we'll enter you in a special sweepstakes. And at the end of the month, one lucky MSDN subscriber is going to drive away in an Aston Martin V8 Vantage. And better yet, we pay for it, and we also pay the tax and the shipping. And we even let you choose which side of the car you want the wheel on. I think we do, but yeah, we do as of now. So, yeah. So definitely, if you haven't tried out Azure yet today and you are a MSDN subscriber, go to Windows Azure, sign up, and you can take advantage of this offer and take advantage of all those dev test benefits, even if you don't win the car, and start taking advantage of it. And if you're not an MSDN customer, but you're interested in Azure, go ahead and sign up to windowsazure.com. There's a free 1-month trial. I think it's $260 of credits that you can use, again, on anything. And hopefully you saw, just in the brief demos today, there's an awful lot of things to take advantage of. And if I leave you with anything, hopefully you saw Windows Azure is flexible. You can do lots of things with it. You can reuse your existing skills, your existing code, both as an IT professional and as a developer. It's very open. You can mix and match and target any type of devices. You can use any operating system, any database, any programming language. And it's very consistent. And it allows you to kind of build solutions that can take the best of your on-premises environment, the best of the cloud, mix them together, or build solutions that can run in your own data center, our data center, or in a third-party service provider. And that hopefully gives you, both as IT professionals, as developers, a tremendous amount of power, and I'm going to let you build some really great things with it. And so I encourage you, visit windowsazure.com to get started today, and looking forward to seeing what you build with them. So thanks a bunch.
Thank you very much. Thank you, Scott. Another round of applause. Scott Guthrie, ladies and gentlemen, visiting us from the States. Awesome. So make sure you sign up, go in the draw for the Aston Martin. If you don't sign up, you get to drive Nigel's Subaru. So still awesome, but not quite as good. Now to those New Zealanders in the room who spent most of that going, is that Windows Azure? Yes, it is. It's the same one. I know with Scott's kind of awesome American accent that we don't have here in the country, many of you were going, there must be a different thing. No, it's Windows Azure. It's the It's like, you remember last conference when Scott was here and he was talking about Windows aluminum? Do you remember that? And it turned out to be Windows aluminium. It's the same one. They just leave. Just wanted to clarify that because I know many people go, that must be a different thing. It's not. It's the same thing. Right, we're going to move on to our final speaker tonight. And this guy, I probably don't need to tell you, is a real show-off. What hasn't he done? He's done heaps. He's a TED fellow. He's a Rhodes Scholar. He's a physicist. He's a track and field champion. And he's an Oxford PhDer. He lists his passions in life as the 3 Ps, physics, politics, and technology. That might not be right, that last one. Please welcome overachieving bloody good guy, Sean Gawley. Welcome him to the stage. Up you come, Sean.
Cheers, Paul. It's fantastic with a PH. Awesome with an O. Awesome with an O. Anyone? O for awesome. Yeah, look, it's great to be back here in New Zealand and kind of amongst people that speak proper, which is fantastic. You wouldn't believe it, but the whole country actually sounds like Scott, which is, you know, what are the chances? So, look, for me here, you know, probably like a lot of you, grew up, you know, loving computers, and the only problem was we didn't have a computer as a kid, so. Dad, of course, being very resourceful, drove the old Holden Kingswood down to the school in Christchurch, and we'd sort of disassemble the computer and bring it back home, and then he'd give it to me as a 6-year-old and say, put it back together, and the reward was, of course, that I could play computer games on top of the computer. So that was sort of Friday through Sunday, and it was great because I didn't have to speak to anyone for that whole period of time. And, you know, one of my favourite games was this game, Gallagher. And, you know, despite, you know, not being very good with people at that age, I got very good with the computer game. And I'm actually very good at dodging the aliens. And, you know, so good that, you know, my parents probably said I was quite special. So, you know, that was nice of them, but they let me alone. And, you know, I got very good at always trying to beat the aliens. But, unfortunately, the aliens would always win. No matter how good I got, the computer always seemed to be better than me. The computer seems like it could go faster, it could make decisions quicker, and it could ultimately outthink me. As I got a little older, I was like, well, you know, no worries. You know, the computer might be able to beat me at simple reaction games, but, you know, I'm getting smarter here. I can think I'm a human. I'm a human, I can think strategically. I can make big decisions. I can make complex decisions. So, of course, 97 rolls around. I'm a little older. I'm in high school now, watching Kasparov play a game of chess against IBM's Deep Blue. And we all watched as this game, you may remember it, kind of unfolded. And unfortunately for humans, Kasparov lost 2-1 to IBM's Deep Blue. Simply put, the computer could simply outthink and move quicker and further ahead than perhaps the best human mind of the world could. And for many of us, this was a story of the triumph of machines over the simple human mind, a triumph of sheer computational horsepower over the biological wetware that we were born with. But for Kasparov, he wasn't so sure. He had been beaten by the machine, but he thought, well, what if I teamed up with a machine? And he did that, and he started to think about creating a new style of chess. And he called this freestyle chess. And the rules of freestyle chess were basically that there were no rules. You could team up with another human. You could have 2 humans working together. You could have a human and a machine. And you could even use psychedelic drugs if you thought that would improve your game performance. Anything goes. And so they run the first championship back in 2006. And in 2006, they have 48 teams from around the world come and enter. It's an online competition. And they could be broadly defined into 2 categories. The headless category, the sheer just computers by themselves. And on the other side, the centaurs, sort of half man and half machine. Humans and machines teaming up to kind of create a better chess playing environment. And as the games went on, it became pretty clear that the centaurs were the ones that were actually starting to dominate. They were dominating so much that, in fact, by the end of the competition, the final 4 came in, and they were all centaurs. 3 of them Russian grandmasters with supercomputer scale hardware, and a little team called Zach S that chose to keep anonymous. You didn't have to reveal your identity. And as the final 4 went on, one thing became very clear is that Zach S started to play some very, very good chess. Some unconventional chess and quite creative chess. And ultimately, it was winning chess. And people used to think that it was Kasparov, perhaps, but the truth is so much better. It was two players. One of them was a soccer coach, and one was a database administrator. The most definitely not, yes, some database administrators there. There's one of them. What are you doing here? But they were able to do that, and they're actually able to do that with consumer-grade computers. They didn't have to throw this up into the cloud or anything. One of the computers actually borrowed from their parents. But the thing that made them so successful was that they knew how to drive these machines. They knew when two algorithms disagreed, which one to go with and which one not to go with. They knew to turn up the aggressiveness of the algorithms or make them more creative. And they knew when to trust their own instinct when the machine was giving them an answer they didn't agree with. Ultimately, they used the machines to amplify and enhance their own intelligence. And so the story here is not so much one of artificial intelligence being used to solve the world's biggest problems. Indeed, it's one of augmented intelligence, a story of man and machine coming together to do things that neither one could do by themselves. And it's an incredibly powerful technology, and one that I believe will give us as a human species a chance to live on this planet as we go forward for the next couple of 100 years. So, simply put, augmented intelligence on the one side. You've got a complex world, and using dimensionality reduction to kind of make it simpler. And you could think of that in the same fashion as an image that's captured with a JPEG compression algorithm, basically capturing most of the elements of the image, but making it with a smaller size. And effectively, that's what you're doing with mathematics, but you're doing that for the whole world model. And on the other side, you're taking this human 1.0, and you're giving them visualization tools so that they can sit in and interact with the computer in a way that's much more human. And somewhere in the middle of that lies augmented intelligence. And one of the things is, of course, used for a lot of different things. One of the things I think quite fascinating that it's used for is weather prediction. Now, weather prediction, here's a storm front rolling into Canterbury. And this is the kind of stuff that's confronted weather forecasters. How do you predict when these storms are going to emerge? And for those of you who live in New Zealand, maybe you think actually not very good at this stuff because we always seem to get it wrong. But it's actually quite a difficult problem. You've got massive nonlinear dynamics, you've got chaos, you've got turbulent airflow, and you're actually trying to build models of the entire weather system. And they do this, and one of the things they actually do is they don't just build the models to make the prediction, but they actually track how successful the prediction was. And so the Americans have got about 60 years of this data, and they're actually able to see and track that through time, and actually see here the 36-hour in the blue and the 72-hour forecast in the red, actually tracking up massively and pretty consistently over the last 60 years. And for most of us, again, this is a story of increasing computational power from the IBM 701 at the start to some of the biggest supercomputers in the world today. Indeed, this increase in predictive performance is being brought about by a 15 billion-fold increase in computational speed. Huge increase in computational speed. And so one of the things, of course, is say, well, what happens when you stick a human with these models? What happens when you stick a human with the output of these models? One of the things we might expect to see is that as the computational power increases, the human delta that the human adds to the improvement of the model actually starts to reduce. But in fact, we don't actually see that at all. This is tracking since 91. You can see in the blue there's machines only, and in the red there's humans and machines. And one of the things that's interesting here is even in the computational power increases during that time period, there's broadly a similar delta right across that area. Simply put, humans and machines are getting about a 16% model performance over machines by themselves. And I think this is just, again, another example of how humans are still going to be relevant. So, this is good for those of us that are humans out here. And one of the things, of course, if we're going to have humans as part of the system to solve some of the biggest problems that we've got in the world, we're going to have to understand the interface between humans and machines. Because whilst a machine will read a matrix very, very well, it'll struggle with an eigenvector. Sorry, it'll do very well with an eigenvector. We'll struggle with eigenvectors and matrices. We like to have things that are a little more tactile. And we need to do this, we actually need to understand the human brain a little bit, because this is the thing we're interfacing with. And it's because of this, there are some things that we just simply shouldn't have machines making the decisions on. Some things that perhaps we shouldn't just feel lucky. Yeah, we'll see if this actually works like that, right? And, we should have humans in the loop. We are important. So experts. You know, some of you out here might be experts. For those of you that aren't experts, you might know an expert. And if for those of you that don't know experts and aren't experts, have a few drinks on Thursday, we'll all be experts. And, you know, we'll be throwing that around. But it used to be that experts sort of were kind of mystical, magical. They had this intuition. They knew what was going to happen in an uncertain environment. We couldn't really quantify it until some smart Chinese scientists decided they'd go and quantify it. And they did that in a breakthrough paper in Science 2011, where they measured the neural circuitry of intuition. And they did this by taking, again, chess, a group of chess players, and they split them into two groups. And on the one side, they had the amateur chess players, the people that knew the rules, obviously, but weren't, you know, by any means professionals. And the other side, they had the professional chess players, and they stuck them both into an fMRI machine and projected images of chessboards up onto the screen in front of them. And they did this for just a second. And they did it for just a second because they wanted to bypass the conscious element of the brain. They wanted to get into the subconscious. And when they did this, they measured with the fMRI, they measured different parts of the brain lighting up. And what lit up very, very distinctly was a region of the brain called the precuneus. And the precuneus was 2 times stronger, or 2.1 times stronger, in the professionals than it was for the amateurs. Now, this is important because the precuneus is associated with pattern recognition. And what this is telling us is that the expert chess players were flashed up for just a second, a complex board structure, and the brain, without them knowing, the brain saw a pattern. Whereas the amateurs, they just saw noise. Once they did this, they then showed up another board, this time for a couple of seconds, and they said, what's the best move? And again, a different part of the brain lit up. This was the caudate nucleus. This is part of the reptilian brain, right down the bottom. Very, very primitive part of the brain, but it's associated with learned response functions. And it lit up for the experts, but not for the amateurs. And it lit up in a very, very interesting fashion. It lit up in a way that was correlated with the prediction. The stronger the signal from the caudate nucleus, the more likely the expert had got the right decision. Again, this is happening in 2 seconds, not enough time for the conscious mind to really figure out what's going on. And so the neural circuitry for intuition looks something like this. You have the visual cortex, which takes in the complexity of the board. The precuneus abstracts this to a pattern that's similar to what's seen, but it's abstracted. And then the caudate nucleus compares this abstracted pattern against a system of learned response functions to determine what the best move is. But this takes a lot of practice. This takes a huge amount of time. If you want to be an expert chess player, you're probably too late if you haven't started. And this is sort of at the heart of expertise. Training the brain to recognize patterns and respond quickly without thinking. We shift the computational part of decision making to the subconscious, and it frees up the conscious mind to do strategic decision making. And so if it seems like an expert is a step ahead of you, it's probably because they are a step ahead of you. While you're trying to figure out the computational part with your conscious, they've already done that and they're thinking about the strategic implications. So that's great if you're an expert. But what if we could build software to do this part? What if we could build software to start finding some of these patterns that exist in our world that experts see that the rest of us don't? And that was sort of the challenge round of talk 4 years ago. We're building a company, Quid. The tagline, augmenting our ability to perceive this complex world. So I want to tell you a little bit about how that came about and where it came from. So we'll take you back to this little part of the world, to Oxford, England, where they shipped me off as a grad student across to England. And it never really snows, but it looks a lot better when it snows, so you get a photo of the snow. But it was in there, and I was over there to study in one of these labs to do nanotechnology, biomolecular motors. And I sort of had spent a few days in the lab and quickly realized that Oxford was a much more interesting place as soon as you got out of the lab. And so I quickly decided that nanotechnology was going to no longer be what I wanted to do. I wanted to do something that involved being outside of a lab and perhaps even involved creating a new discipline that I could make up more of the rules myself. But it actually had a few advantages because it started to introduce me to people that were in philosophy, that were in economics, that were studying international relations. Took to a lot of dinners where you talked to soldiers that had come back from Iraq and come through Afghanistan. It actually gave me a very, very interesting perspective, one I think that's missing with a lot of the more narrow focuses on science. And it was at one of these dinners. I was sitting down at high table. It is pretty much like Harry Potter, surprisingly. You sit in there and you have your cap and your gown and you sit down and you have a 5-course meal. Life's pretty tough, I'll assure you. Sitting down, and actually happened to be sitting next to me was the former head of the CIA, James Wolseley. And we were debating about the upcoming conflict in Iraq. And suffice to say, we're on different sides of that debate. I won't say who was on what side. But he was giving stories and conjecture and argument, and I was like, well, that's fair. All right, yep, I get that. I don't agree with it, but I get where you're coming from. And I was saying the opposite. But we're sitting here trying to pull apart the complexity of human conflict, one of the most chaotic and unpredictable systems, using anecdotes and ideologies. And for me as a physicist who'd spent time sitting in a lab playing with nanotech, I was like, we've got to do a little better than this. And so the first thing I wanted was some data. And of course, you know, I'm 21 years old and I'm at Oxford and the world's at your feet, right? So you go to the Pentagon and sit down and asked for some data, and they said, no. So I was like, oh, all right, fair enough. So they said it's classified, confidential. You've got an accent. Why do you want this? Yeah, right. So I consoled myself by watching hours of Fox News. We report, you decide. No, seriously. But as I watched that, I realized, this is apocryphal, didn't really happen this way, but it's a good story, that there was data down the bottom of these, at the bottom of this information stream. This information that's sort of ambiently surrounding us, and we sort of hear the opinions and the sort of faux debate of the people kind of chatting away, but underneath it is data. You know, there is a bomb that goes off, people do report it. And it started to think, well, you know, what if we could start to collect this stuff? And this is exactly what we did. We built up a system that would monitor all of the cable news, all of the newspaper reports, blogs, big in 2002, had just come online. We started to monitor them. We didn't have Twitter, but we did have New York Times reporters going out and text messaging back to the Bureau, a kind of an early message of Twitter. We put all that stuff through and we had to teach ourselves natural language processing to read these documents. And we started to assemble a database together, and we got pretty good at it. We didn't know how good we got at it until our good friend Julian Assange, he's not really a friend, that would get me in trouble, anyone? But he released, the Americans are watching this, they won't let me back in the country. He released the data from the US Significant Events database from Iraq. And we're able to compare our data that we'd collected using open source, freely available information processed using natural language processing. And we had 81% of the data that the US military had, the entire US military had. And that was pretty good. But it's even better because they only had 70% of the data that we had. 3 people on laptops in Oxford, more information than the entire US military. Like, this information landscape has changed. And we saw that. We saw that open source intelligence had about a 15% increase in event-based data. It's a pretty significant change in the landscape of intelligence. So at that point, actually, the Pentagon was quite interested. They didn't want me to take the data out of the Pentagon once I brought it in, but I said, you wouldn't give it to me to start with, so it's mine now, so whatever. But we took that and we actually analyzed it. We're actually looking for mathematical signatures, ways in which this would look different from random. And one of the really strong signatures that we found was to do with the size of attacks. And we can see it here for Iraq. The size of the attacks versus the frequency plotted on a log-log graph. And you see, to the first order approximation, you've got a power law distribution with an exponent alpha equals 2.31. And kind of take that in. That's data. That's people fighting, killing, and doing everything else that war does. And you see the almost unreal correlation that exists through that. It gets even stranger because that's for Iraq. The same pattern exists in Afghanistan, Colombia, Sierra Leone, Northern Ireland, and Senegal. When people get together to kill each other, they behave in strikingly predictable mathematical fashion. And once you do this, the first thing everyone says, well, can you predict the next attack? And the fact that the statistical correlation says you've got a pretty good shot at predicting. But it's kind of the wrong question, because why would I want to predict that 3 kids would die in northern Baghdad tomorrow? Why wouldn't I want to change this? And this is hard because if you have got a predictive model that's based on inductive rationale, i.e. the future will look like the past, how do you change the world? To do that, you actually have to understand the system that you're dealing with. So we came up with equations that govern the insertion dynamics that would replicate the statistical signatures that we were seeing. We coded this up into computer simulations so that we could run different scenarios, more troops on the ground, attack the large groups and not the small groups, put peacekeepers in. We actually started to create simulations that would do that, and we got pretty successful. We got so successful we actually had the cover of Nature in 2009. And this kind of represented the high point of an academic career, and for me, a lot of long work. But it was while I was in Iraq that a couple of things came to mind. I was up walking in the hills there, and a couple of things. The first was, why am I doing this? This is not a good idea. And can I get my camera back? I don't know who that guy is. But the second thing was, I was like, I'm doing this in the academic world. And the academic world, on the back of an envelope, it sort of looked a bit like this. There was $300,000 in academic money and about 6 people working on this. And I sort of, as I was walking down through those hills, I was like, I think this is going to take a little more. Probably about $100 million perhaps, and maybe 1,000 people. And then I sort of kept walking and thought, well, that's not going to happen. But as I came back, I started to realize it was a magical place. San Francisco, venture capital, where your wildest dreams will come true. But seriously, a place where you could actually go to get this kind of money to chase crazy ideas. The crazy idea to create software that would map out the complexities of human dynamics and make it available to all the decision makers in the world. I was lucky enough to meet a man named Peter Thiel, who fronted up with the first round of angel investment and gave me $2.5 million to get things started. And that was great. And it led on to kind of building Quid, which is now into its 4th year, operating in downtown San Francisco with German minimalist design functionality. They like that in Germany. It doesn't actually look like that now that we actually work there. And our library, because I felt very guilty about not going to the library at Oxford. So, but more importantly than that, there's a great team of 52 of us, including 6 New Zealanders that are out there at the moment. New Zealanders we hired straight out of Auckland University, some of the best developers on the team. And we are hiring, so at some point look me up, because you too can sit and play on the blackboard. That's not a developer, that's a kid. Yeah. And so yeah, Quid software, it's been up and live, deployed for the last 6 months, and we've actually got a pretty nice range of customers across everything from NASA, the DoD, through to good old Microsoft, who's been an early client for a long time now, and down to Red Bull, and they do throw the best parties if you're ever in LA. Sugar water. And they ask kinds of questions like, what's the most effective way to allocate capital to spur growth in K-12 education technology? That's like high school. Or what are the dominant narratives about climate change in India, and how does it vary with age groups? Or what are my competitors doing with advanced flexible display technology, and should I compete or partner with them? And these are kinds of questions that they're asking that are very, very difficult to answer. The same kinds of questions like, should I send more troops to Iraq or not? The kinds of questions that you, as a human, perhaps cannot solve by yourself, but you simply wouldn't push a button and say, I feel lucky. I just want to tell you a little bit today. This was one of my favorite ones when we signed up NASA. This is like all the sorts of boyhood dreams coming true. This little space startup down in Silicon Valley there. And we worked with them because they were trying to understand the nature of the global space industry, particularly as these these players such as Elon's SpaceX would come in and start to disrupt it. And I want to take you through today what you can learn if you were to plug into the software, and what you would see if you were to go and understand the global space industry. We'll do that in about 5 minutes, and hopefully you get something out of it. Now, if you were to go to Google or Bing, probably Google, or Bing might have more articles, I don't know, but Google will come back and say, we got 4,200 articles for you, human, and we've done it in 0.17 of a second. And I've picked the one just for you. But if you were to try and read those 4,200 articles, you'd be there for about 2.5 weeks if you did nothing else but read them. So whilst it's kind of good on some level, it's not really great for what we want to do to wrap our heads around the global space industry. Instead of that, if we could turn that list of 4,200 articles into an interactive, dynamic user interface that we could play with using all of our human sensibilities, that would be fantastic. And so we can do that by actually taking those articles, stripping out the text, running in natural language processing on top of that, pulling out vectors that take key engrams that describe the text that's in front of us, and effectively creating a digital signature or vector of the information around. So you can see here something that might look like a document. We then take that and compare it against every other article that we've collected, looking for comparisons to see if there's meets a certain threshold. If that's done, we create a link between the two of them. And ultimately, you start to form a network. Now, this is a network of implicit connections, of similarity. And we start to visualize the way the landscape of the space industry unfolds. So that's kind of what it looks like in theory. We'll have a look and see what it actually looks like in practice. This is now the Quid software. You jump in, you're into exploration mode. The yellow dots, each one represents one of the 4,200 stories. You kind of see the headlines and the titles. And of course, each story doesn't exist in isolation. It's connected to other stories that are kind of similar. And not every story is equal, so you might want to go and change the size of the story based on the number of connections or the number of links. And all of a sudden, some structure starts to emerge. But it's not spatially relevant, so we want to apply a physics engine to this so we can actually start to get some spatial structure here. Now what happens is the similar stories cluster together and the different stories fly apart, and all of a sudden a landscape starts to emerge. And so we'll take that and kind of zoom in, and now we'll go and apply some clustering algorithms on top of this to find the communities, and they'll color it into certain ways where similar stories have the same kinds of colors. And we can actually open that up into full screen and go and take a look at what's happening. So we see here a cluster of stories up into the top about NASA and the budget and how they've really got no money left. And then we come across and we see that's affecting the science collaborations with the European Space Agency. And then we can kind of come down through the middle. You see a few stories around cyber defense and cyber security. And then come down to kind of an interesting cluster here around GMD kill vehicles, missile defense shield. And you think, well, is that still being funded? But obviously it is. And then you kind of zoom back out and start to get a sense. You can go and explore, much like you'd explore a Google map. But you've actually got, instead of maps, you've actually got a landscape of ideas. We can apply an algorithm on top of this that'll search for kind of relevant names for these clusters. And we'll start to make computational guesses about what's going on. And so all of a sudden here, this is the 4,200 articles presented in front of you in a way that you can now start to actually explore and interact with. A few things that pop out here. NASA and the budget. It's a big topic of conversation, or so we think, but it actually only occupies a very, very small part of the network. A bigger one is actually around the US military here, and we see the US military kicking in with missile defense, Earth observation, and commercial satellite imagery. But far and away, the biggest part of the global space industry is not NASA, it's not the US military, it's actually satellite communications. It's satellite TV, it's mobile broadband, it's the communication and data going up to the satellites and bouncing back. This is, by and large, what the global space industry is actually about. And so if you were to get an expert to kind of draw this out, as we did at NASA, and said, sketch out what you've got, very, very interesting exercise, but they'll get out literally on the back of a napkin and kind of draw the different elements. Now, this is a projection of their cognitive model of the industry, what they hold in their heads as being an expert. But again, we want to try and get a computer to do something that's kind of similar so that anyone can be an expert in that space. And you do that, and of course, 3D is always a nicer way to do it. You can actually start to see now, this is the topics that cluster in and the connections that are around them. And it's fully interactive, where you can go and explore and see what's happening. Again, the computer's done all this for you. See, at the heart of that European Space Agency connected up to mobile broadband and satellite launch vehicles. So it's an interesting way to see what's happening there. If we zoom back out, and we can actually apply a coarse grain filter now, and this is interesting because what it does is it sort of splits the landscape into two pieces. And you can see from a human's eye, this is broadly speaking, the United States and the rest of the world. A lot of things are actually like that. But what's interesting is what exists at the cusp, at the borders. There's a couple there. You can see one around the US military and a second around the commercial crew. So let's actually go on and zoom in and see what actually the interface of the US and the rest of the world looks like. And if we actually go in, we can zoom and enhance. You always got to zoom and enhance. You can see the White House calling for export control reform. This is really fascinating because now this is the White House has got laws in place that forbid any space technology to go overseas out of its borders. It's called ITAR. And it's fascinating because it's actually stopping them access the commercial launch vehicles that actually dominate the global space industry. And so as the money starts to run out for NASA, of course Obama starts to think, well, how do we unfold these export things which were more relevant for the Cold War? If we zoom back up to the top, we see this is around the commercial crew, and we see the NASA chief, Bolden, going across to China and actually starting to make overtures to the Chinese Space Agency. Why? Because pretty soon the US no longer have the capacity within NASA to launch people into space. China actually does. And as China gets more and more involved in this industry, the actual landscape that we see will actually change with it. So that's kind of the stories that are happening, but of course within each of these stories are a bunch of entities. You know, companies, people, and government organizations. We can of course pull these out and start to understand them. And to do this, it actually borrows kind of heavily on a lot of work from the, that I did a couple of summers ago, where I spent the summer up in the High Sierras, up in Yosemite National Park, chasing around alpine meadows, looking at food webs, particularly looking at the nature of what would happen when you put a new species into the food web, in this case a brown trout. What species will thrive, which ones will become extinct. It turns out the mathematics behind this, so the networks that we're looking at, are actually quite similar. But instead of it being a brown trout, it's SpaceX, and SpaceX partnering with Tycom and other satellite launch players to change the nature of that ecosystem. So we can sum all that up and we can actually start to see where SpaceX fits into this ecosystem. You can see it's very strongly connected down to Boeing, but also up to Arianespace, the French company. And again, now you can explore the partnerships, relationships, and structure of all the major players in the global space industry pulled from these open source documents. But you can do that even better in 3D. And now you see thousands of objects and tens of thousands of connections. SpaceX at the top in red, its first order connections in yellow, second order connections in green. And at this point, you've gone beyond even what an expert holds. An expert will not hold this level of resolution in their mind. And you can do this as a fairly novice to actually see the structure of the industry that's in front of you. You can explore it, you can do what humans do, get lost, ask questions, look for patterns. And you can do this not just for space, you can do this for any industry you want. You can do it for any document set you want. You can do it for patents, for scientific publications. You can plug this into your Bloomberg data and actually understand the market structure that goes with it as well. And I've got to take my hat off to the team, and particularly some of the Kiwis on this that have made this stuff possible, because I think it really is quite beautiful and you know, a much nicer way to interact with that information that's around us. So this is the next part of this. This is narrative analysis. Now, I really wanted to go and use this to understand Microsoft, but I was told in no uncertain terms that I shouldn't broach the topic of CEOs being changed because it would sort of reveal Scott Guthrie was going to team up with Sergey Brin and would sort of spoil the markets for everyone. So we had to apply this to a different topic, in this case sugar water. So we're taking the top 6 CEOs of the top 6 beverage companies selling sugar and caffeine into the world, and we want to look at what their global footprint is, what messaging they're putting out to the rest of the world, how they want to be perceived, how they are being perceived, and how it's different from each other. The first thing that pops back from this is we can see that Howard Schultz at Starbucks gets around 22% of the news volume, and Muhtar Kent at Coca-Cola comes in second at about 19%. But what's interesting is not so much the volume of news that they get, but what it is that they're talked about. So looking first here, here's the footprint, and we can project onto that Howard Schultz's clusters. We can see everything from basketball through to gay rights and also Green Mountain coffee acquisition, where you can have more organic coffee every morning. But the two dominant clusters for Schultz are actually these two that are shown here, and these really are the kind of things that he's most known for based on his media footprint. And this is his statements around Schultz, incompetent lawmakers are sapping the lifeblood of the government. It goes off on a dysfunctional Congress, and indeed the American dream is in jeopardy. This is the CEO of one of the major companies projecting this language out. You sort of wonder how he can get away with that. And it's sort of because this is right next to it. And this is around the investment of $25 million into Square. And it really drives the narrative that Starbucks isn't just a company that sells you sugar, water, and caffeine. It's a tech company. And if you're a tech company in America, you actually get to play by different sets of rules. This is a really important strategy that's been pushed out. This is far and away the dominant story around Schultz. Muhtar Kent occupies a different part, the CEO of Coca-Cola, you can see there, and we can zoom in on that and actually see things around low-calorie push, but also the move into Burma after being out for 60 years, and a little bit there around the growth in India. Project that up into 3D. This time we use the Z-axis as the amount of social amplification through Facebook and Twitter that the message has got. And we can go and explore that and see the stories that got amplified. We can also see the stories that didn't get amplified and get a sense of which message we might want to change or how we might want to direct it in a way to project a different image based on getting you to try and avoid perhaps the US sales taxes on sugary beverages. So a powerful tool to start to think about messaging, as well as a powerful tool to understand industries. And you can see perhaps it being used in this scenario here. And Occupy Wall Street, a massive political movement running through America and indeed around the world. And a really interesting testbed, a sort of laboratory to understand the nature of political communication. So we can project here all the documents around Occupy Wall Street, overlaid on top in yellow everything that talks about inequality. You can see up the top you've got very much the street. You've got the schism between Occupy Oakland on one side and Occupy New York down the other. Kind of divorced from that is the political discussion down the bottom, where a lot of the words of inequality starts to emerge. And you can actually see them being quite distinct, using quite distinct language and different topics within that. But more interesting than that perhaps is seeing that evolve through time and actually tracking the conversation as it moves, seeing what stories stick, what stories resonate, how the protesters are being characterized, how they're characterizing the government to go with it. And you realize it's a very, very powerful tool for both messaging and propaganda. And it doesn't take a lot of maths to think about how this might be used for today's conversations around Syria and the march to war over in that part of the world. So we live in a world that's incredibly complex. And it perhaps is more complex than our human brain can actually wrap its head around. And it's certainly more complex than the best machines that we've got can solve. But we still have to make decisions. We still have to decide and take actions. We don't get out of this game just because it's too difficult. And I believe it's extremely important that we throw our best resources at building technologies that allow us to understand this world so that we can actually live within it and hopefully thrive as a species so that one day we can get off the planet and go and explore the rest of the universe. And I'm building augmented intelligence to help us do that. And it's been a great journey over the last 4 years, and hopefully the next 4 will go just as well. And we get a few more Kiwis on board to help make this dream a little more real. So thank you for your time. And again, we're hiring.
Thank you, Sean. Sean there, man, he is really brainy. Did any of you guys get that? Just me, really brainy. It's amazing. But really, I think he should just probably decide on one thing. You know, being amazing at all those things is a bit much. I hope you've enjoyed all the keynote speakers this afternoon. You have? Yes? Put your hands together for them. If you have, excellent. Fantastic. Only remains now to welcome back to the stage to close this evening's event, Mr. Nigel Parker. Give him a round of applause, please. Up you come, Nigel.
So with that, I'm going to draw the TechEd Keynote to a close and welcome you all to join us for a drink at the Office 365 Hub downstairs. Thank you.